Okay, I'm feeling like this is going to be a long video. There are 17 slides, but this is slide number 1. We're going to be busy today. All right, little b. Simplify square root of 169. You can do that on your calculator, or you can try hedging it. The problem it is 13. That's one of those that I told you needed to memorize. I told you to memorize first 15. Remember, the negative goes in front. 50 we're going to hedge. Divided by 2 is 25. Divided by 5 is 5. Divided by 5 is 1. There's a pair of 5s, so we bring out a 5 and leave the square root of 2 inside. Set this one up, and then go off to the side or down to the bottom and hedge 72. Divided by 2 is 36. Divided by 2 is 18. Divided by 2 is 9. Divided by 3 is 3. Divided by 3 is 1. Pair of 2's brings out a 2. Pair of 3's brings out a 3. 2 times 3 brings out a 6. Left inside is 2. Outside numbers get to multiply. 12 times the square root of 2. All right. Okay, now I'm allergic to bees, so I don't know. I'm like breaking out in hives as I'm watching this video. And he's kind of scary looking, but we're just going to say, whoa, look at that bee. So cool. I do like honey, though, so what can I say? All right, so what I'm checking for here is, are these even? Remember, if they're not even, we're going to rewrite them, but they are even. So I'm going to hedge 81. Is there a square root of 81? That's one I memorized, guys. It is 9. What about the square root of a to the 4th? Remember, you just take 4 divided by 2. That brings out a perfect a squared. For the square root of b to the 8th, you take 8 divided by 2. And that brings out b to the 4th. There's nothing left inside. That is a perfect number. On this one, this is odd, so I'm going to rewrite it as 30. I'm going to rewrite that a cubed as a squared and I'm going to leave the b squared because it's even. I'm going to go down here and I'm going to hedge 30. 30 divided by 2 is 15, divided by 3 is 5, divided by 5 is 1. There are no pairs. Absolutely nothing comes out. So I'm going to leave that 30 inside. For the square root of a squared, 2 divided by 2 is 1, so I'm bringing out an a, but that still leaves an a inside. For the square root of b squared, 2 divided by 2 is 1, so I'm bringing out that b, and I have no b's left inside b's. No b's for you. All right, this one I'm going to rewrite also because the 5 is just 5, a to the 4th is even, b to the 9th is not, so I'm going to write it as b to the 8th and b. Is there a square root of 5? There is not. It's a prime number, so it stays inside. I'm done with that one. Square root of a to the 4th, remember, divided by 2 brings out a squared. Done with that one. B to the 8th, 8 divided by 2 is 4, brings out a b 4th. Done with that one. B, it's odd, it's 1, it stays inside. You always have the 1 left inside if it's odd. Okay, these are one of the hardest things for us to remember how to do because it doesn't follow along with our hedging right off the bat. We want to see, can we reduce 1 over 3? We cannot. So we are rationalizing by multiplying both of them by the square root of the denominator. Then everything inside up on top gets multiplied. 1's inside, 3's inside, that gives me a 3 inside. Everything on the bottom inside gets multiplied. 3 times 3 is 9. Square root of 3 does not reduce. The square root of 9 is 3. I cannot simplify those because 1's inside, 1's outside. On the next one, the very first thing I'm going to do is say, ooh, this reduces to 1 over 2, just because I want to work with smaller numbers. So I have the square root of 1 over the square root of 2. To rationalize that, I'm going to multiply by the square root of 2 over the square root of 2. Then multiply all the insides up top. 1 times 2 is 2. All the outsides on the bottom, or the insides on the bottom. 2 times 2 is 4. So I end up with the square root of 2 over, and the square root of 4 is 2. If you didn't do that, if you left it as 6 and 12, you would multiply both of them by the square root of 12. That gives you the square root of 72 over 12. Remember, when we have the same inside number twice, we just write it. Then you have to hedge 72. So I'm over here hedging. I bring out a 2 and a 3. So I would have 6 outside, square root of 2 inside, and 12. Then the outside numbers I have to reduce just like I did when I learned fractions in 4th grade, and I get the same number. So trying to simplify first makes your life easier. On number 9, it makes your life a whole lot easier. Does 18 over 3 reduce? It reduces to just 6. Is there a square root of 6? Nope. So that's your answer. Okay, so this guy is really watching you. Do you know the difference between solve and factor? Solve means you've got to get x equals. That's what this whole unit's about. I only see one variable term, so I'm going to set this up square root plus or minus square root. I have x squared over here, 64 here. Square and the square root cancel. 64 is one of the numbers I memorized. It is 8. So my answer is 8 and negative 8. On number 11, I also only see one x term. The squared thing is all alone, so I'm going to set it up as square root equals plus or minus square root. This is x minus 4 squared, and this is 36. I just rewrite the problem with those square roots. The square and the square root cancel, leaves you with x minus 4. Plus or minus. Is there a square root of 36? There is. It is 6. Now, when I add 4 to both sides, remember, I have x equals, I sneak the 4 in front and then the plus or minus 6. I have to take the two roads. If I take the positive road, 4 plus 6 is 10. If I take the negative road, 4 minus 6 is negative 2. Notice I get two answers. This is really two answers too. This is 8 and negative 8. All right? Quadratics, that little square tells you you're going to get two answers. All right, now see, that bee's pretty. He's not quite as creepy looking as the other bees. All righty, I'm going to add 10 to both sides. So I have 4x squared equals 32. I'm going to divide both sides by 4. So I have x squared equals 8. Then I'm going to go to the square root thing. Remember, the reason I'm doing the square root on both sides is because I only have one x term. The square and the square root cancel. Over here, I'm going to hedge 8. So I'm going to divide by 2. And I'm going to bring out 2. So it's going to equal plus or minus 2 outside, square roots of 2 inside. Okay, even though there's a lot of stuff going on here, there's still only one x term. So I'm going to start by adding 5. You do this just like a regular equation. You always get rid of the addition or subtraction first by moving it to the other side. Then I've got to get rid of the 3. It's being multiplied, so I'm going to divide it. So I have x plus 2 quantity squared equals 10. Now I'm down to square equals square, so I do square root equals plus or minus square root. So x plus 2 squared and 10. Square and the square root cancel, so you get x plus 2. I'm going to try to hedge 10. Absolutely nothing comes out, so I'm going to leave it as plus or minus the square root of 10. When I subtract the 2, remember 2 is outside, 10 is inside. I cannot add and subtract, multiply. I can't do anything with outsides and insides. They both have to be insides or both have to be outsides. Sneak the negative 2 in front, plus or minus the square root of 10, and that is your final answer. Okay. Here, oh, look at that last picture. There was only 2 of them. Now there's 4. They're calling all their friends. And the reason that we have more is because, look at, now I have 2 terms. So I could try factoring. Are there factors of negative 7 that add up to negative 4? No. So I'm going to go to the quadratic formula. Guys, I'm getting lazy. I'm just going to do the discriminant over here. B squared minus 4ac. B is negative 4 squared. Minus 4, a is 1, c is negative 7. So this is 16 minus 4 times negative 7. 16 plus 28 is 44. So x is going to equal 4, opposite of b, plus or minus the square root of the discriminant, 44, all over 2 times a, which is 1. So 4 plus or minus all over 2. I'm going to try to hedge 44. Oh, I bring out a pair of 2's, square root of 11. Remember, when you bring stuff out, you now have to look at all of your outside numbers. Do they all divide by the same thing? They all divide by 2. So your final answer is going to be 2 plus or minus 1 times the square root of 11 all over 1. I lied. That's not your final answer. Get rid of those little ones because you don't need them. 2 plus or minus the square root of 11. Okay, again, there are two. Oh, that's just creepy looking. That just sends heebie-jeebies up and down my spine. But you know, there are a lot of people that love bees and they raise bees, and good for them because we need bees. I just don't want to take care of them. Everybody has their own thing. X squared minus x minus 12 equals 0. Are there factors of negative 12 that will add up to negative 1? You got 1 and negative 12, nope. 2 and negative 6, nope. 3 and negative 4, yep. So I'm going to do factoring here, okay? So x squared plus 3x minus 4x minus 12 equals 0. Group it out. Take an x and an x plus 3. Take out negative 4, x plus 3. Don't forget the equal 0. So you have x plus 3 times x minus 4 equals 0. So x plus 3 is 0, which gives you x is negative 3. X minus 4 is 0, which gives you x is 4. If you had done the quadratic formula, you would have had x equals negative b plus or minus, and your discriminant would have been, I'm going to my calculator and cheating here, guys, 1 minus 4 times negative 12 over 2 would have been the square root of 49 all over 2. So you would have 1 plus or minus 7 over 2. Let's see if this works. 1 plus 7 over 2, 8 over 2 is 4. 1 minus 7 over 2, negative 6 over 2 is negative 3. Whew, got the same answer. You can do it either way. All right, on this one, I am going to subtract 4b, and I'm going to subtract 3. So I have 2b squared minus 7b minus 3 equals 0. Okay, if I try factoring, are there factors of negative 6 that add up to negative 7? You might think there are, but negative 6 and negative 1 doesn't work because that multiplied together gives you a positive 6. So the answer is no. So we're going to find b squared minus 4ac. b is negative 7 squared minus 4, a is 2, c is negative 3. So 49 minus 8 times negative 3, 49 plus 24, 73. So b is going to equal the opposite of 7 plus or minus the square root of the discriminant all over 2 times a. B. Look, she did b's because there's b's. I think that's funny. 2 times 2 is 4. Is there a square root of 73? The answer is no. 73 is a prime number. You could have tried 2, 3, 5, 7. None of them work. You are done. It does not simplify. Okay, 4x squared plus 16 equals 0. Oh my gosh, so many things you could do here. But if you know, oh, that is a beautiful flower. If you notice there's only one x squared term or one variable term, you could solve this using the square root method. So 4x squared equals negative 16. Divide by 4. X squared is negative 4. When you have just the one x term, you're going to do the square root thing. X squared and negative 4. Square and square root cancel. Uh-oh, I've got the square root of a negative number, so there is no real solution. If you had done the discriminant, b squared minus 4ac, remember here, a is 4, b is 0 because there's no x term, c is 16. So it would have been 0 minus 4 times 16, 0 minus 16 times 16, 0 minus, that's not 196, I believe it's 216. I don't trust myself. 256, see, don't trust me. So you would have gotten negative 256. Remember in a couple slides or a couple times ago, I told you if the discriminant is a negative number, you can stop right there and say no solution. Okay, that's where I told you you were going to be at an advantage to doing that. All right, I'm going to bring the 4a over, and I'm going to bring the 4 over. So I get 3a squared minus 4a minus 4 equals 0. Let's just do the discriminant here. There's a lot going on there. I don't see it right off the top of my head, so let's do it this way. Negative 4 squared minus 4 times a times negative 4. 16 minus 12 times negative 4. 16 plus 48 is 64. Oh, it would have factored. Okay, I know that because it's a perfect square. So a is going to equal the opposite of b, plus or minus the square root of 64 all over 3. Is there a square root of 64? It's one that I told you to memorize. It is 8 all over 3. So a is going to be 4 plus 8 over 3, 12 over 3. A is going to be 4. A is going to equal 4 minus 8 over 3, negative 4 over 3, so it equals negative 4 over 3. So just because I feel the need to do this, are there factors of negative 12 that add up to negative 4? Yup, negative 6 and 2. So that one would have factored if you wanted to do it by factoring. All right, I'm going to bring the 2 over. So I have x squared plus x plus 2 equals 0. Are there factors of 2 that add up to 1? No, you'd have to be able to subtract. So we're going to go to b squared minus 4ac. b is 1, a is 1, c is 2. So 1 minus 4 times 2, 1 minus 8 is negative 7. What's that tell you guys? There is no real solution. Remember, if your discriminant's negative, because you would have ended up with this when you went to the quadratic formula. No real solution. Oh, that discriminant being a negative number, it's kind of like a gift from the little algebra gods. You're done. There's no solution. Sides of a square are increased by 10. So this is x. If I increase it, this becomes x plus 10. This was x. If I increase it, this becomes x plus 10. The area, which is length times width, is 289. And this is the new area. So that's x plus 10 times x plus 10. So 289, there we go. X times x is x squared plus 10x plus 10x plus 100. So just keep bringing that 289 down right now. X squared, combine like terms. So you have x squared plus 20x plus 100. Now I'm going to subtract the 289. So I get x squared plus 20x, that's a 20, minus 189. Let's do that discriminant thing over here, okay? b squared minus 4ac. b is 20, 20 squared minus 4, a is 1, c is negative 189. Okay, now you know I'm going to stall because I'm going to have to go to my calculator for that. 400 minus 4 times negative 189, which is 400 plus 756, which is 1056. Now, guys, that's a huge number. I'm going to hit my square root button, and I'm going to find out that the square root of 1156 is 34. So when I go back over here, it's negative b, which is negative 20, plus or minus the square root of 1156, all over 2 times a, which is 2 times 1. We just found out that the square root of 1156 is 34. So I have negative 20 plus 34 over 2. 14 over 2 gives me x is 7. Negative 20 minus 34 over 2, negative 54 over 2 tells me x is negative 27. Can a side of a square be negative? Nope. So the original square was 7 by 7. You always get 2 answers, but only one should work. The product of two consecutive even. So that means x is my first, and if it's even, I have to jump 2 to get to my next one. Product means multiply, so x times x plus 2 is 168. I'm going to distribute. X squared plus 2x equals 168. I'm going to subtract the 168. So x squared plus 2x minus 168 is 0. 168 is a pretty big number, so rather than factor that, I'm going to find the discriminant. B squared minus 4ac. So 2 squared minus 4 times 1 times negative 168. 4 minus 4 times negative 168. Remember, you got to do the multiplication before the subtraction. So negative 4 times negative 168 is 672. So 4 plus 672 is 676. So I have negative b, negative 2, plus or minus the square root of 676 all over 2 times 1. Okay, guess what, guys? There is a square root of 676. It's 26 all over 2. So from here, x could be negative 2 plus 26 over 2, which is 24 over 2. So x would be 12. Now, if that's true, what's x plus 2? 14. So there's one set of numbers that it works on. Remember, x could also be negative 2 minus 26 over 2, negative 28 over 2. So x would be negative 14. If x is negative 14, what's negative 14 plus 2? Negative 12. There's your other two numbers. Oh, so much work. All right. A 5 by 7 inch photo. So this is 5, this is 7. Is in a frame of uniform width. The area of the photo and the frame is 63. Now remember, this is x, making this whole thing x plus 5 plus x, or 2x plus 5. This is x, making this whole thing x plus 7 plus x. That's the worst 7 plus in the world, isn't it? Or 2x plus 7. So when I do area is length times width, 63 is 2x plus 5 times 2x plus 7. So 63 is 2x times 2x is 4x squared plus 14x plus 10x plus 35. So 63 is 4x squared plus 24x plus 35. I'm going to subtract 63. Guys, I'm going to be honest. I'm going to my calculator here. I'm just not trusting myself. 4x squared plus 24x minus 28. I could divide everything by 4, but since I know the quadratic formula, I'm just going to go over here and find out b squared minus 4ac. Let's see what I get. b is 24. 24 squared minus 4. A is 4. C is negative 28. So I am going to my calculator because I don't know these. And I hit square root instead of square. What is goober doobs? And so I have 576 minus 16 times negative 28. Negative 16 times negative 28 is 488. Becomes positive 448. I wrote the right thing, said the wrong thing. Plus 576. So this is 1024. So go to the quadratic formula. X is negative 24 plus or minus the square root of 1024 all over 2 times a, which is 2 times 4. Is there a square root of 1024? There sure is. It is 32 all over 8. So we have two answers. We can say it is negative 24 plus 32 all over 8. And negative 24 plus 32 is 8, and 8 over 8 is 1. Or it could be negative 24 minus 32 all over 8. That would be negative 56 over 8, which is negative 7. Remember, x is the width of the frame. It cannot be negative. So the width of the frame is 1. Oh my gosh, there's one more left, guys. All right, the width of a rectangle is 3 meters less than the length. So this is the length, this is the width. It says the width is 3 meters less than the length. So whatever the length is, it's 3 less than that. The area, which is length times width, is 70. So 70 is the length times the length minus 3. I can't use length times width because I have to use the same variable, okay? So 70 is L squared minus 3L. I'm going to subtract 70. So 0 is L squared minus 3L minus 70. And I see this one, so I'm going to go ahead and factor. The factors of negative 70 that give me negative 3 are negative 10 and 7. So I've got L squared minus 10L plus 7L minus 70. All right, so I'm going to pull out an L. I get L minus 10. I'm going to pull out a 7, and I get L minus 10. So 0 is L minus 10 times L plus 7. So if L minus 10 is 0, the length is 10. If L plus 7 is 0, the length is negative 7. Can the length be negative? No. So the length is 10, which means the width is the length minus 3, which would be 7. So the length is 10, the width is 7. Could have done that from here using the quadratic formula. If you do that, your discriminant would be negative 3 squared minus 4 times 1 times negative 70. 9 minus 4 times negative 70. 9 plus 280, which is 289, and it does have a perfect square. I don't know about you guys, but I'm exhausted. Let's stop this video.